Today we're going to go over stoichiometry. This is on page 49 in your notes, so you can follow along with the note page on page 49. So stoichiometry sounds intimidating, but it's just a fancy way that we express proportions, and it's what we call mole ratios, and we get mole ratios from balanced equations. So our first step is going to always to be balancing the equation, getting our coefficients. Another term for coefficients is known as a mole-mole ratio. So we'll be using coefficients, the big number, in what's known as the mole-mole ratio. Remember before we talked about when we dealt with the mole, if we had one, we always told you to put 1 with mole. Well, that was until we get to stoichiometry. It's going to be 1 mole as long as it's not the mole-mole ratio. If it's the mole-mole ratio, then we're going to be using coefficients. So we're just going to do 4 different types of problems. They all really kind of work the same. It just depends on what you're starting with and what you're ending with. So if we look at this first equation, so we've got silver nitrate adding with magnesium chloride, making magnesium nitrate and silver chloride. This is a double replacement reaction. If you want to pause for a second and see if you can get this balanced, and then you can start the video again after I balance it. I'm not going to walk through the balancing, so please message me if you need help with the balancing. But this would get a 2 coefficient, and this would be a 1. You do not have to write 1s, a 1 and a 2. So there's our balancing. And this is a double replacement reaction. Double replacement or displacement, because silver was with nitrate and magnesium was with chloride. Okay, so now we're going to start with the math. So it says if you begin with 0.1 moles of silver nitrate and excess magnesium chloride, that's just there to help us write the balanced equation. So this means we've got more than enough. So I'm going to have you mark through that and excess, because that's a little bit of a distractor. How many moles of magnesium nitrate can be made? So what we're going to do is I'm going to underline what I'm going to start with, and maybe I'm going to circle what I'm looking for. Not circling very well there. Alright, so when I taught this to high schoolers, I would have them identify what I call the given and the wanted. So this might help some of you definitely won't need this, but the given is what I've given you. Basically it's what I've put there in green. I had 0.1 moles of silver nitrate. And then the wanted is what I'm looking for, and I'm looking for moles of magnesium nitrate. Now this actually could be done with your brain, but we're going to use the smaller type to set up the bigger type. So up here, hopefully you can see for every 2 of these, I'm getting 1 of those. So if it's a 2-to-1 ratio, so you might figure out the answer without doing the stoichiometry here. But so here we go. We're going to begin. So we're going to begin with the number that we were given, and the unit, and the label. So that's how much silver nitrate I have. And I'm going to convert it, so now we'll bring mole down. Now, I'm not going to automatically put a 1 there. And the reason I'm going to put a 1 there is because I'm getting ready to do stoichiometry. So 1 doesn't always go with the mole if we're doing stoichiometry. And what stoichiometry is, it allows you to switch from one compound to a different compound. I intentionally made these different colors so you could see that my compounds are different. So I was green and now I'm blue. So notice my unit is still mole, but my compounds are different. That's stoichiometry. And so stoichiometry is using the balanced equation to figure this out. So what I'm going to do on top here is I'm going to switch my colors, and I'm going to switch the label. And this can only happen with this special thing called mole-mole ratio. It's the word mole and the word mole on top of one another. That's the only time you're allowed to have your labels different. So the labeling, this is a unit, this is a label, is different when you have the mole-mole ratio. And where you get those ratio numbers is up in that balanced equation. So in front of the magnesium nitrate, there was a 1. But in front of my silver nitrate, there is a 2. So down here, I'm going to put their ratio numbers. In the balanced equation, this one was a 1. And in the balanced equation, this one was a 2. Those are the coefficients from the balanced equation. So this is going to mark out. And so I'm going to stop this problem because, see, I've got moles of magnesium nitrate in the top corner, which is what I want. So basically, I'm just going to now divide, and I'm going to get 0.05. Beginning zeros are not significant, so I'm going to go 2 more to get 3 significant digits. So that is called the mole-mole ratio. You don't have to know the types of stoichiometry, you just need to know how to do it. So it's starting with the mole of one thing, going to the mole of something else, using just the simple mole-mole ratio. Alright, we're going to move on to the next one. So the next one is called, and the steps are here for you later when you want, if you need to read them. So it's called a mole mass. Basically, I'm going to start with the mole of one thing and end up with the mass of something else. So I've got sodium plus chlorine, diatomic, that's why you're seeing Cl2, making sodium chloride. This is a synthesis reaction. Synthesis reaction. So if you want to pause for a second, see if you could balance that, and come back and I will balance. I'm not spending the time on the balancing. So it is 212 is our balancing numbers. Alright, I am going to write my given and wanted just in case. I'm just going to put G and W. So I have been given 0.5 moles of sodium. That excess chlorine, not worried about. And I'm looking for, I'm going to red this time. This time I'm looking for grams of sodium chloride. So I'm going to start out with 0.5 moles of sodium, which is Na. And I am looking for grams of sodium chloride. So not only am I looking for a different substance, I'm looking for a different unit as well. So I'm doing quite a bit of movement there. So I'm always going to start with my given, 0.5, which is the number that I've been given. We put that over 1. I'm going to bring mole of Na. Now, I cannot put grams NaCl here because the only time the labels can be different is with the mole-mole ratio. So I can't switch to red here. I can switch to red since mole's here, but I can switch to red, so those can be different. But that word right there needs to be mole. It cannot say grams. I can't say the grams of salt equals the moles of sodium. Okay, it has to have the ratio, and we're going to get those ratio numbers in front of our balanced equation. In front of NaCl there is a 2, and in front of sodium there's also a 2. Even though it's still a 2 to 2, you must write it. Now if I stop right here, I would have moles of sodium chloride. I'm not looking for moles of sodium chloride, I'm looking for grams. But now do you notice I've switched it to red? I got it switched to the right thing now. So then I'll do moles of sodium chloride to grams of sodium chloride. Whoops. NaCl. Now, anytime mole and grams are buddies, this is not a mole-mole ratio. So anytime this is known as molar mass. So mole will always get a 1 with grams. 1 mole of sodium chloride equals so many grams. Not using Avogadro's constant, I'm using molar mass, which is 1 sodium and 1 chlorine off the periodic table, and that equals 58.5 grams. Okay, I would multiply and divide, and I would get an answer of 22.3 grams of sodium chloride. Comes out to be 22.25, but for sig digs 29.3 grams of sodium chloride. I wrote it correctly, just didn't say it correctly. All right, next problem. So our next problem is getting a little bit bigger. Well, not necessarily bigger, because that one was kind of big. It's called the mass mole problem, because we're going to start with the mass of one thing and go to the mole of something different. And so down here I've got a double replacement reaction. Calcium's with oxygen and sodium is with phosphate, and our front guys have switched places with one another. So this is a double replacement. This one's got some polys in it, so might be a little harder. So if you need a pause for a second, see if you could balance it, then start it back, see if you got it right. So some of you need more practice than others. So here's our balancing numbers. All right, so we're going to get my given and my wanted. I've been given 17. Let's get colorful there. How about we do some purple or something? The pretty color. Okay, we've got 17 grams of calcium phosphate. Calcium phosphate is Ca3PO4 2. Phosphate's a 3, calcium's a 2. I've swapped dropped. So that's what I've been given. And it says how many moles. So I am looking for moles of calcium oxide. So moles calcium oxide. Alright, here we begin. 17.0 grams calcium phosphate over 1. What's going to come down? Grams calcium phosphate. I left off my 2. I cannot switch it to green. I can't switch to green at all. And the reason I can't switch green is I don't have the mole. Mole has to be right here before I can switch it. So I cannot switch to green. So I still have to be Ca3PO4. Still has to be that. So it can't be grams of it, so it must be moles. Anytime mole and grams are buddies, mole gets a 1. So here we would add up the molar mass. I would add up 3 calciums, 2 phosphoruses, and 8 oxygens. I would get a molar mass of 310.3. You can take a second and see if you get that. So 3 calciums, 2 phosphoruses, and 8 oxygens. So I'm not done. I do have moles, but I don't have the mole of the right guy. So I'm going to keep going and bring mole down. Calcium phosphate. Alright, now that mole is down in this bottom right corner, now I can switch it to calcium oxide and specifically mole. It has to have mole-mole ratio. The only time the colors can be different. If you like colors, this would be good for you. Okay, this time right now, everything going on, we need some color in our lives, right? So if we like to switch colors, the only time the colors can be different, which is the mole-mole ratio. We're going to get those numbers in our balanced equation. There is a 3 in front of our calcium. Whoa, my pen's not wanting to write up there. 3 in front of the calcium oxide, and in front of the calcium phosphate there is a 1. So it's not always 1 here, but it just so happens that ratio. So do you see those are canceling? And look what's in the top corner, mole. So I've got what I want. Let me switch back to the color I want. And I would get a 0.164 mole of calcium oxide. Alright, hopefully you're following along. One more. One more is probably the most common one. It's one we use most often. It's when we know the mass of one thing and we're looking for the mass of something else. And so we have a combustion reaction here. Combustion is always some sort of hydrocarbon plus oxygen making carbon dioxide and water. Remember, that is a redox reaction. Everything's a redox reaction except for double replacement. So singles, synthesis, decomposition, they're all redox reactions. Doubles are the only ones it's not. Alright, so here we go. If we balance this, pause it and see if we can get it balanced. If not, there's a 2 there. and a 2 there. Okay, so now we have our given and our wanted, and our given was 16.5 grams of methane. What colors do we want to use? There we go. And there's that excess oxygen I don't need to worry about. That would just help me write the equation. And I guess we'll go by red. And I'm looking for grams of water. Should have done that one in blue. It's okay. Grams of water. So we're going to begin with 16.5 grams of methane. Let me move that down. That line is bothering me. Here we go. A little bit better. 16.5 grams of methane. I would bring grams of methane down. First question, can I switch colors? The answer is no, because this is not moles, So I gotta go to mole of methane first. Anytime mole and gram are buddies, mole gets a 1. I'm going to add up the molar mass of methane, 1 carbon and 4 oxygens, which has a molar mass of 16 grams per mole. So that'll cancel. Alright, if I stop there, I have moles of, this is what we did back when we just did mole problems. I would have mole of methane. I don't want mole of methane, so I'm going to bring mole of methane down. Mole of methane is down, so now I can switch it. I can switch to a different color. I'm going to go to mole of water. In front of our balanced equation, in water there's a 2, and methane there's a 1. So 2 water, 1 methane. 2 waters, 1 methane. If I stop, right now I'm going to have moles of water. I'm not looking for moles of water, I'm looking for grams of water. So I've got to take it out a little further. Mole of water to gram of water. Here's gram and moles as buddies, so mole will get a 1 and grams will get a molar mass. And you might even have water memorized by the time we did those hydrates. It is 18 grams per mole. So that will cancel. We will multiply across the top and divide by the bottom, and I got a mass of 37.1 grams of water. So there are the basic types of stoichiometry. Next time we'll do limited reagents, which is what I call stoichiometry 2.0. So these are our basic types of stoichiometry. Please email me if you have any questions.